Hi, this podcast is for CNT140. We're looking at Chapter 15 on testing and certifying LAN wiring. So our objectives for this one is really understanding why we're going to certify. What do we mean by scanner performance? Understanding certifying our cabling, different methods we use, equipment we use, that sort of thing. All right, first thing we need to recognize is the major reason to specify standards-based LAN, as we said before, if we install our LAN based on standards, everything should connect up and work as it should. So when we do that, the specification, the standards are specifying the cable plant design that will meet our performance. So if we need, gigabit to the desktop, if we install block cabling a certain way, it'll meet that need. The next things we specify is the actual cable and connecting components. Category 6 cabling, Category 6 patch panel, Category 6 outlets. All those would meet that performance level. And then the last thing is proper installation techniques. Half-inch untwist, 4 times the cable diameter for bend radius. All those things, all those pieces go together using a proper design, using all the proper components, and using the proper techniques. When we're done, we should have a cable system that supports gigabit to the desktop. All those pieces got to go together. So we want to discuss the cable and components certified by the manufacturer. How do we perform certification on the installed cable plant, the actual tester itself, and as we get to lab, actually how to use this tester and certifier installed cabling. All right, we've known this a long time. Primary standard for LAN performance is 568C. Specifically, if I get into 568C2, this talks about our testing techniques and the level of performance. So if I pull up my standard, where are you, standard? Here he is back here. Here's my 568C2 standard. I'll zoom in just a little bit. If I scroll down, the first thing they talk about is link test configurations and then the performance level. So if I buzz through the first page or two here, this talks about the channel and permanent link tests, how they're configured, and then the next couple pages talk about the electrical parameters and then all the test data that I should be getting for a certain category of cabling. So my C2 standard is key in this performance levels, how I'm going to certify, and then the performance levels it needs to meet. That's all included in the C2. It used to come out of, I should say, this started from standards like TSB 67, TSB 95. These were all rolled into 568B and then updated in 568C. Some of that history that, oh yay. We know our component performances category 3, 4, 5, all that sort of thing. 7 they're working on. They're even working on 8, kind of in the works, if you will. We do know the manufacturer is responsible for testing these components. For them to be able to put a stamp on the side that says certified category 6, it had to have been tested and verified. The manufacturer is probably going to do it themselves, but then they also usually have an outside lab test and verify, and then that gets stamped on the side of the cable. And we've seen, if we think back, UL stamped on the side. That's usually safety. If we're saying the cabling is plenum rated, UL is going to try to light that sucker on fire and see what kind of, how it's going to burn and what kind of fumes and everything we're going to get off of it. So they're going to test some of the safety stuff. And people like ETL, Electronics Testing Laboratories, that's been rolled into Intertech or something like that, some other firm. They're going to test and verify the actual performance, the bandwidth, the frequency ranges, those sorts of things. They're going to test that, and if it passes Category 6 standards, boom, they can put a stamp on the side, ETL verified to Category 6 blah, blah, blah cabling. So if we think back and look at the stamps and the labels on the side of the cable, we saw stuff like this. That's what that's meaning. We are responsible for, when we're installing our cable, we're responsible for using the proper components. Well, we've been doing that all along. Category 6, patch panel, Category 6 cabling, Category 6 outlet jacks, Category 6 patch cables, all that, we're responsible for doing that. And also, when we're done, field testing. So after we're done putting everything in. We've done some basic tests on it with, continuity checker and wire map to see if everything is installed correctly, but we also need to certify to see if it's going to handle the bandwidth we want it to do. And that's going to be using a new meter we have not used yet, our cable certification meter. This can be done by us, our company, if we have the equipment to do it, the company we hired to install our cabling, or we can have an independent third party come in. And it is going to cost money to do this. I usually use the analogy here of having your car inspected. Okay, so bear with me here a second. We're going to need our cabling certified so we know it passes a certain performance level, and then we can say, yes, it will handle gigabit to desktop. That's very much like taking your car to the garage and having it inspected. I'm going to take it in, they're going to double check all kinds of stuff, wanting to make sure it's safe to be on the highway. And if it is, they're going to put a sticker on it saying, yep, it is safe to be on the highway, and they're going to charge you money for it. Because they did a service, they had the tools, they had the equipment to verify everything was as it should be. Well, that's very much the same as certifying our installed cabling. When we're done, we're going to have a special meter hooked up, a cable certification meter hooked up, run tests on it to verify it will handle gigabit to the desktop kind of thing. When they're done, they'll document it, they'll print out the results, and they're going to charge us for it to do this certification. Very much like having a car inspected or something of that nature. So they usually end up charging so many dollars per drop to do this, or maybe it's rolled into the labor of the install, that sort of thing. But that's what's going to happen, and it's really there to verify this installed system, once it's in and in place, will perform to blah level. Gigabit to the desktop, 10 gig to the desktop, whatever it is. And it's going to be done with tools like so. We have not seen these yet. We have not talked about these yet because we haven't really needed them yet. We need a cable certification meter like the Fluke cable analyzer, or the next one I have here, our Ideal LANTech series certifier. We actually have two of these very similar. One that looks identical to this and one that's just like one model earlier than. We have two of these cable certification meters that we'll be using in the lab. Now, real quickly, let me pop up their page. If I were to go look them up online, here's the Ideal page, LANTech 2 Series Cable Certifier. These are the only ones that can actually run the performance tests to certify the cabling. Everything we used up to now was letting us know that we had a complete path and what the complete path was. This is the only thing that's able to test the performance things like attenuation, neuron crosstalk, those kinds of things. So here's the Ideal LANTech certifier, and like I said, we have two of those. And then here's the Fluke counterpart, the cable analyzer. Okay. Now, if you were to go buy one of these, you're in the $10,000 category. These usually start at $10,000 and go up, depending on the extra batteries, cases, straps, all the little goodies that you get with it. Depending on what you get with it, they're usually in the $10,000 category to start with, just to give you an idea. So many companies do not have these because that's a substantial investment. And this also goes back to why, when you're contracting somebody to do this, you're going to pay for it because you're paying for their time, their technicians, and this equipment. So, just like when having your car inspected, you're paying for that that knowledge, that those tools, those equipment to do that. All right, so we're going to come back and talk about those testers some more and the tests we're going to perform, and you're even going to do that in lab. So just bear with me as we kind of keep going through the chapter here. They then talk about installing Category 6 when you only need 5. And we've said this all along. What really matters is all your components are the same, and your system is as good as the weakest link. So if I install, let's put new cabling in, and you put Category 6 cabling in, but you still use the 5E patch panel, 5E outlets, 5E patch cables, this system is going to be capable of 5E performance, if you will. It's only as good as the weakest link. So as we've been saying all along, it's really an issue of when you do it, you do the whole shebang, you do the whole thing. That's the best way to do it. You're only going to get that performance if you do the whole thing. Categories of performance. All right, we've been talking about that all along. A cable or connector is manufactured to meet a specific performance level, Category 5E, Category 6, etc. Manufacturers are required to test these components, and verify that they do. That's how they're able to put the stamp on the side. And again, they're going to do it, and they might even have an outside lab do this. Well, bear with me here a second. Let me show you some of that. If I go to a place like Mohawk Cable here, this is their Category 6 page, I can download some data sheets from them that show me the performance level of these. So let me go to, here's your Mohawk Cable. Here's the Mohawk Cable data sheet for the Category 6 LAN plenum rated cable. This gives you all the specs on it. Even part numbers and so forth. And as I go down to this next page, they start showing us the insertion loss values, near and crosstalk values, etc., etc., etc. They have to do this. And what's even this is good. This is manufactured by this is put out by the manufacturer, so it should be good data. But what also has to get done in many cases is this needs to be certified by an outside company, so they can say, yes, this truly does meet that level. So here is a sample of a, here's an outlet jack. Same thing for an outlet jack. You have the outlet jack and then the standards that it's meeting, and down here they start giving you some specs on near and crosstalk values, insertion loss, all that kind of good stuff. Again, this is put out by, in this case, Panduit, the specs on their outlet jack. But what usually needs to also happen is an outside firm needs to run it. And this Intertech, I think this is the overall body that ETL is under, or I think ETL was bought out by Intertech. This is an outside certification firm, and their test result on that Category 6 Panduit outlet jack. And as they went through the whole process, they're saying, yes, it verified, blah, blah, blah. And here is the technicians that did it that verified that it does meet Category 6 standards, etc., etc., etc. Here it is, Category 6 connecting hardware. So, coming back to what we were talking about, let me get my right page here. It's back here. I know it is. It's back there. Actually, I'll just do it this way. I'll minimize, minimize, minimize. There we go, there we go, there we go. So coming back here, manufacturer is required to do this, but what usually becomes more value is when you have an independent laboratory do this, and then a certification is issued that, yes, it does meet that performance standard. So as we look at a category, as we look at a jack and we see Category 6, that's not taken lightly. That actually had to have been tested, had to have been verified, and usually an outside company does that to say, yes, it does meet Category 6. That's why we told you all along, look for that label on there to let you know. The standards for these, or the performance standards for these, again, are outlined in 568C2 if we're dealing with copper, C3 if we're dealing with fiber. And I showed you that earlier. As you scroll through, there's just chart after chart after chart of if it's going to meet Category 6 standards or Category 6 level, it has to have blah attenuation or blah near and crosstalk value or less, if you will, for it to be able to meet that. And that's all laid out in the standard. And that's why, if it meets Category 6 standard, it's fulfilling all those requirements. The book mentions pluggable connector components, and they say 568C calls for 200 insertion withdrawal cycles. If you dig through I think you actually found this in 568B and so forth. You really don't find it in C, but what it amounts to is our components, like our outlet jacks and so forth, are designed to have a certain amount of life, but they're not going to have infinite life. So the standard had called for it needs to be able to do blah cycles or more. And what you really find is if you start digging up specification sheets for like outlet jacks, most of them are designed for like 700 or 800 insertion cycles. And what that means is it's going to wear out over time, and eventually you will need to replace it. But there's a pretty good life in these things. You think about an office where you kind of plug things in, it stays there for probably multiple years without being unplugged and plugged in. But they're making a point that these things do have a finite life. You cannot use them forever, these outlet jacks and so forth. The connectors itself also need to be tested for attenuation near and crosstalk. And again, the standard calls for the acceptable levels on these for acceptable levels near and crosstalk and attenuation. All right, let me pause there. When we come back, we'll keep going.